Okay, so this video is just going to walk through the example that we have for our axonometric projection question that is presented in week 6 lab. So as you can see here, what we're going to basically do is complete this bit of a construction at the start to complete any one of these axonometric projection questions. Now, depending on if you're completing a diametric, trimetric or isometric version of the drawing, the angles between the z, y and x axis change. So as you can see here, for our isometric, which we're doing now, the angles that we're going to be dealing with is 120, 120 and 120. So basically it's equal all the angles between each of the axes, as you can see here. Now, what the difference really between isometric, diametric and trimetric is just the way that you are looking at the object itself. So to give you a bit of a real world example, I'm going to crack out our planes of reference, which you all should be familiar with by now. Here I've just recreated our z-axis, as you can see here, our x-axis and our y-axis. Now what I've put in here as well is our horizontal plane, which is below here, which you draw your plan down onto or project your plan to. You have your vertical plane, which you project your elevation in, and then you have your invertical plane, which you basically project your end view into. Now it doesn't really matter if you call this the invertical plane or this the vertical plane. It just depends where you want to put your elevation. Now, in relation to this model here, depending on how you're looking at it, so for instance here, I'm just going to try to line up as best I can that this would be an isometric view. Now, this is just by eye, so what I can see by lining it up like here, I can see the angle between there and there is around 120 degrees, which it should be for my isometric as well, 120 here and 120 here. If I was to tilt this in any direction, it now becomes a different type of axonometric question, because if you see here, if I tilt it all the way to the extreme, you see the angle between the z and the x actually becomes a straight line. It becomes 180 degrees. So as long as I have this in the orientation where the angle between the y, z and x axis are all 120, we are looking at it as an isometric. Now what we're going to be doing is we're going to basically be dropping an object into the center there and creating it. But to do that, we have this construction where we basically draw an elevation, a plan and an end view to construct it in isometric, as you can see it here. And we're just going to complete that now using the drawing. Now this drawing, I would say, would be one of the drawings that would take a small bit longer than usual to complete. Not that it's particularly tough, it just takes a small bit of time to do it. At any point during this video that you feel that I am going too slow and you want to speed it up, all you have to do is go into the settings on the YouTube video and just speed it up to maybe 1.5 speed or 2, depending on if I'm still making sense when talking. So what I'm basically drawing here is my 3 different axes. I always have my axis that's going vertically up, straight, up, vertical, perpendicular to the drawing itself, and that will be my y-axis. And then I also need to draw on my z-axis, which will be coming out this direction, and my x-axis. Now, because we're dealing with an isometric, remember it's 120 between each of them. What I can do, because I know that this is 90, and I also know that if I use my 60-30 degree set square here, that if I go like this, it'll be a 30 degree from here to here. So now I know that there'll be 120 between here and here. So all I have to do is line it up like so, draw my line, extend it out. Now I'm going to have this bit darker like usual so you can see what's happening. For you, you can keep this all nice and light because it's all construction. Take my 60-30, turn it around like so, and draw it down. Okay. Now what I've done is I have my 3 different axes, 120 degrees between all of them. What I can do then is I can identify what's what. So this is going to be my z and this is going to be my x. Now I've just positioned this in the page so it's in the center, so I have a bit of space below to draw my plan as well as to draw my elevation and end view if needed. Now I will definitely need one of either the elevation or the end view for this particular drawing. Depending on how complicated the drawing is, you might need an additional view. usually you can get away with just 2. So that would be end elevation and plan, or elevation and plan. Now for the purpose of this, I'm going to draw the construction as if I was doing all 3 views, but I'll only complete the 2 that I need. Now I'm just going to construct the traces that I'm going to be using. What I do to do that is just I get a parallel line with the bottom of my drawing, so I use my T-square, draw a line like so. It doesn't really matter, just keep the triangle somewhat small, so as you can see here around the scale that I'm using. Use your 60-30 again. Up like so. Jump around. Join it back up. Now again, this would be distorted. It would look a bit different depending on what type you're using, or what type of drawing you're doing. If it's an isometric, it will look like this. These angles will just change. It will be the same construction, it'll just be the angles between them that will change. And if you want examples of that, just give it a quick Google search, have a look through your David Anderson's graphics book. They'll have plenty of examples of various constructions using isometric, diametric and trimetric. Now what I can also do is, keeping the line straight, I extend each of my axes out the opposite direction. So for instance here, my x-axis, I'm going to continue it back out this direction like so. I don't know where it stops yet, I'll just bring it a bit out. Same with the other ones. Like so. Then I'm going to bring parallel lines to each of them out from each one of the corners here of the triangle, or the trace that I've basically drawn. This lanima that's basically sitting there, and the traces that I've drawn of it as it sits in the corner. So as you can see, they're nice and parallel. Try to be as accurate as possible. Now the issues you can run into here is when you're making this construction, you could either place this in a wrong location so that things are overlapping. You could basically draw the elevation and plan, which I'm going to be constructing above here and below here, too close to the drawing so it overlaps, or even too far away so it runs outside the drawing. So just be careful of that. Now, if that does happen, what I would suggest, rather than starting all the ways over, is just getting another page up here, putting a small bit of tape so it's held in place, and then drawing onto that. Now I'm just going to keep this nice and consistent by measuring out. It's just to ensure that I keep it far enough out that I still have space, and like I was saying before, it doesn't overlap on either side. So I'm just going to go 80mm out on both sides. Now, depending on how accurate you have been, when you swing an arc, basically, or a semicircle, from this central point out here and around, they should line up perfectly. If there is any bit of an issue with basically drawing this construction in the center, it will throw off your lines a small bit. I won't be worried if it's a small bit off, but try to keep it as good as possible, ensuring that all the measurements themselves are right, or the proportions. So you can see there, my arc lines up perfectly with this corner up to the corner above. Like so. Now you can see that here it's just the tiniest bit off to the right. That's just a small bit of inaccuracy when I was dropping down one of these lines. I wouldn't worry about it. If it's as small as that, it won't throw you off. Now for this, all you have to do to finish off this construction, or basically the setup before starting actually drawing the object, all you do is join each corner here back to this point where each axis is extended and pierces through that arc. Now again, depending on if it's isometric, diametric or trimetric, this line actually might be, let's say, further down here, and you'll see a different angle being drawn here with this. Now it's also important to note, no matter what point, let's say this is here, so let's say if this pierced through here, when you join up the far left and right hand side, it will always make a 90 degrees. So no matter where it is, the line from here to here, it will always make 90 degrees between it. So now that we have this complete, I'm just going to label a few different things so you know what they are. So like we were saying before, with our model here, you can see that this is going to be our vertical plane. So this is where our elevation is going to be. So this is actually it here represented. So this is going to be our VP. And over here, this is going to be our horizontal plane. And as well as that, below here, this is going to represent our plan. It's going to represent our elevation. And this is going to represent our end view. Now for this, I don't think it's going to be necessary for an end view looking at it. But if it turns out, as I working on the drawing, it becomes necessary, I'll just draw it in and drop it in. But from me looking at it here, I can see that I can locate all the different points by completing my elevation, my plan. And that should be the case as you see me complete it. And also it's important to identify that these lines here, they basically represent the trace of a plane. So you can imagine that this is actually a flat surface that's just cutting through here, here and here. That is actually flat. So as you're looking at it, your line of sight, it's actually perpendicular to your line of sight. And that's what it's representing. So I'm just going to indicate this line here. It's a trace, as well as this line and this line. So now that we have the construction completed for our isometric, what we can do is we can start drawing in our plan first of all. To do that, what I like to do here is break down my measurements. So instead of measuring over, let's say 8, 8, 16 and 8, I like to, let's say, first of all go over 8, then I add 8 and my 8. So I'm going first of all over 8 millimeters, then I'm going over 16 millimeters, all the way from this edge, let's say, across. The reason I'm doing that is because if I do it this way, I'm less likely to have a cumulative error as I'm reading along my set square and marking off the measurements. If I just keep moving on section by section every time I'm measuring it, what could happen is half a mil here and half a mil there, and it will add up by the end of all the measurements I have knocked off. It could be, let's say, 5-6 mil out, which you know, is actually a fairly big thing, especially when you're dealing with drafted drawings. So we have to try to be as accurate as possible. So 8, 16, 16, 16, 32, 32 and 8, 40. Okay. So I'm going to knock them off. 8, 16, 32 and 40. Okay, now I'm going to do the same thing going out in this direction here. So I'm going to have, I'm going to need this line here, the back line, so that's 16 in, so I have to go 16 first. Then I'm going to need to go the full 48, and now I'm going to need to come back 16, so full 48 and then back 16. Okay. So I'll go my 16. My 48. Leave the set square and go back to my 16. And that should knock out any accumulated error. Then I just need my 45 degree because of doing my isometric, knowing that this should represent 45 degrees depending on how accurate I was, and it does. Now if I was doing this and it was a trimetric or dimetric, it probably wouldn't work out like this. You'd probably need to use sliding set squares. Just ensure that any of your lines that are traveling in this direction are going to be parallel with the side here, and any lines traveling in this direction down are going to be parallel with this line over here. Now again, nice and light, you basically knock off a grid. And then afterwards you can go back and you can outline the important parts. So I know this outer line here, that's going to be inhibit. The outer line here is going to also be inhibit. Now again, this is not representing your finished solution. This is still construction. I'm just going to outline it a bit heavier here so you can see nice and clearly. Okay, I'm going to have this surface, which is going to be from here to here. It's actually a slope surface, as you can see it there. It's a slope surface, but looking from on top you can't really tell. It's going to be extended out one. Okay, so I have my different surfaces here. As you can see, this surface is representing a slope surface above here. This surface here is representing a flat surface here, which looks like a bit of an L. Then we have this box looking here is actually representing this surface here, which is sloped. And then we have this kind of an L structure here again, which is representing this surface here. Okay, so that's my plan completed. Now what I need to do is complete my elevation over here. What I'm going to do is say my elevation is looking in from here. I could say my elevation is looking from here, and then I'd be constructed above here. So now that I'm constructed over here, I'm going to have to knock off first of all my different lengths. Going my 16. Going 16 from this side. That should be all the points. Yeah, and I can always come back. 16 and 8, so I'll go up 16 first. 16 and 40, 56, and then 12 is 78. Sorry. Yep. Like so. Now I'm just going to pack up my adjustable set square. This is going to save me from using sliding set squares. Like so. Then when you've completed, you can basically link your different surfaces. So as you can see here, this surface here is representing this surface. This whole surface here, L, is represented as a line here, as you can see, because it's an edge view, because we're looking in from this side. This surface here is represented here. This surface here is represented back here. And this surface here is represented above here, as you can see. So now what we can do is start bringing back different lines and make sure that they're parallel with your axis. So for instance, your x-axis here that's extended, make sure that any line coming from here back is coming parallel with that. And then let's say that point below in plan being brought up perpendicular, which is going to be parallel to your y-axis. So for instance here, I'm just going to draw the box in which this is going to be contained within. So basically the floor itself, so that bottom, let's say, rectangle that's going to be there underneath. So to do that, what I need is this corner here brought straight up. Corner here be brought straight back. Now I've it located right there. Now what I can do is locate the top part of that corner, bring that back, and where that makes contact as well, where it comes up. Oh, sorry, I have the first point located in the wrong area. It should be here and it should be here. Sorry about that. So I know that's going to be that corner there. So you see that line? That's represented by this line here. Now what I'm going to do is draw the rest of that front surface. Straight up. So you can see where that brings back, intersecting here. So it's going to go straight up. I can finish off the surface. So what I'm going to be doing is just completing that procedure again and again till I have all the different points located and construct the full object as it sits here inside here. So what you can do, if you'd like, you can speed up the video. All I'm going to be doing is repeating the same construction just till I have all the points found. If there's any sections that you get stuck on or you're not too sure about, just slow down the video and you can watch along. And that's the drawing basically completed. As you can see there, basically all the different points, I just identified them both in my elevation and in my plan. So for instance, like this corner here, this corner below here, one came down parallel with the lines of the x-axis here, and one came up parallel with the y-axis, and where they convened was that corner there. So I just did that, kept locating the points. There's a lot of points, there's a lot of lines on the go, so just be sure that you stay concentrated, you follow back your lines, you see where they're coming from. If it helps, do number the different corners. So let's say call this 1 here, call it 1 here, and call it 1 here. As well as that for, let's say 2, 1/2, and then 2 here, and you can find the different points that way, whatever suits. As well as that, just take your time is the main thing. As you can see there, I didn't need my end elevation. Sometimes depending how complicated the drawing is, or if there's curves and things in it, you need that end elevation to see it from that particular angle and bring back the points.